In triangle ABC, AB equals 3, BC equals 4, and CA equals 5. Circle omega intersects AB at E and B, BC at B and D, and AC at F and G. Given that DF equals EF, and DG over EG equals 3 over 4, then the length DE equals A root B over C, where A and C are relatively prime positive integers, and B is a positive integer that's not divisible by the square of any prime. What is A plus B plus C? We have this triangle ABC, which has side lengths 3, 4, and 5, and we also have circle omega, which intersects AB at E and B. So it's at one point B here, and another point E somewhere up here. It also intersects BC at B and D, so the other point D is somewhere along BC, probably over here. And AC at F and G. Those are the 2 points where the circumcircle of triangle BED intersects AC. We know DF equals EF, and DG over EG equals 3 over 4. So we can write DF equals EF, and DG equals 3 over 4 times EG. So the first thing we can say about this configuration is that angle B is a right angle because the side lengths of the triangle are 3, 4, and 5. 3, 4, 5 is a right triangle. And so that means DE is actually the diameter of circle omega. Let's draw that in. And the other two angles, DFE and DGE, are also right angles because they both cut off the diameter. So let's label that. We know those are both right angles. And from DG equals 3 over 4 times EG, we know that triangle DGE is similar to ABC because the leg lengths are in the ratio 3 over 4, and it's also a right triangle. So we can write that triangle DGE is similar to triangle ABC. So now let's do some angle chasing. It looks like triangle AEF is isosceles. So let's try to prove or disprove that triangle AEF is isosceles. Well, we have angle A here and angle AFE here. So note that angle AFE is equal to 180 minus angle GFE, which is equal to, by cyclic quadrilaterals, that's just angle GDE. That's just equal to angle A, because triangle DGE is similar to triangle ABC. So angle AFE and angle A are the same angle. So we can say that this triangle is isosceles. We can do a similar thing on triangle FDC. We want to prove that, or disprove, that angle F and angle C are the same angle. Note that angle CFD is just angle GFD, and that's equal to angle GED. And since triangle DGE is similar to triangle ABC, we have that angle GED is just angle C. So the triangle is isosceles again. So we can say that this triangle is isosceles. Great, so we now have two isosceles triangles in AEF and FDC. But we know that EF and DF are actually the same length. It's given in the problem, DF equals EF. The equal sides of these two triangles are actually all the same length. Let's call that X. So we want to label X, 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 and X. Now, what is X? Well, it turns out X can be found in the following way. So we have that AE is equal to X, and therefore EB is 3 minus X. BD is equal to 4 minus X. And because EFD is a right triangle with both leg lengths equal to X, the hypotenuse DE is just X root 2. So we have the Pythagorean theorem, and we can use that to apply on triangle EBD to solve for X. Because we know that 3 minus X squared plus 4 minus X squared is equal to X root 2 squared. So 3 minus X squared is just 9 minus 6X plus X squared. And then 4 minus X squared is 16 minus 8X plus X squared. We know this is equal to X root 2 squared, which is 2X squared. But X squared plus X squared equals 2X squared. That's good news. So we only have 9 plus 16 minus 14X equals 0. 9 plus 16 equals 14X. So So we have 25 over 14 equals x. Now what do we want to find? We want to find DE, which is x root 2. So we have DE equals 25 root 2 over 14. And it wants us to express this in the form a root b over c, where a and c are relatively prime positive integers. 25 and 14 are relatively prime positive integers. And b is a positive integer not divisible by the square of any prime. It's clear that 2 isn't divisible by the square of any prime. What is a plus b plus c? We just have 25 plus 2 plus 14, which is 27 plus 14, and that's equal to 41. Thank you for watching my YouTube video, and please follow my channel if you would like to see more videos.